Everyone talks about the weather, but it took the government to finally do something about it. What you say with a doubtful look on your face? I can see it. You mean they outlawed bad weather just like King Arthur did in Camelot? Well, not exactly. But they, the National Weather Service and the FAA, do understand what a huge impact weather has on your flight planning. And they know that you'll make many decisions based on all the weather wisdom available to you. So to benefit you, they've come up with aviation weather information in several formats, some of it textual and some of it graphic. Some report the actual conditions at a specific time, others forecast anticipated conditions for specific times in the future. So let's discuss the sources you can use to make your flight planning decisions. And as you might imagine, since these are government reports, they use a little different language than you're used to. Flight service specialists will interpret the data for you if you speak with them directly. But there are other services, including the FAA's Direct User Access Terminal service called DUATS, which you can access via your own computer. But before we get into this weather language, let's talk about clouds and define some terms. Most people think of clouds in a non-aviation sense. Do I wear my shades, lug an umbrella, or don my mucklucks today? Well, as a pilot, you need a tad more information about the clouds than that. You need to know if you can fly safely underneath, in between, or above them. So the FAA and the National Weather Service have divided cloud coverage into the following categories. SKC or CLR mean none, there's no clouds. Few means exactly that. Up to 2/8 of the sky is covered. SCT for scattered is 3/8 to 4/8 of cloud coverage. BKN for broken is 5/8 to 7/8 coverage. And OVC or overcast is 8/8 or the sky is covered with clouds. Now VV stands for vertical visibility, which means you've got an indefinite ceiling. The bases aren't real distinct. They'll also tell you if there are CB cumulonimbus clouds or TCU towering cumulus clouds in the area that you're interested in. Now, since the flight rules refer to ceilings, you'll probably want to know how the FAA defines a ceiling. Ready? A ceiling is the height above the ground of the lowest broken or overcast layer or vertical visibility into an obscuration. Now, for those of you who prefer your answers in English, what this really means is a ceiling is the height of the lowest layer of clouds or stuff which covers more than half the sky. And that stuff, what the FAA calls obscurations, can be ground-based, like fog, or at some altitude, like smoke. Now, with that out of the way, let's see if we can pick out the ceiling from these three different cloud layers. Here we've got a lower scattered layer, an intermediate broken layer, and a higher overcast layer. Let's say that the lower layer is reported as 500 feet scattered, the middle layer is 800 feet broken, and the top layer is 1,100 feet overcast. The issue is, which one of these constitutes a ceiling? Well, by definition, a scattered layer is not a ceiling, so that 500-foot layer is out. Now, how about the 800-foot broken layer and the 1,100-foot overcast layer? Which one of those is the ceiling? Well, it's the 800-foot broken layer because it's the lower of the two cloud layers that by definition can constitute a ceiling. Now, one of the weather observations that reports these ceilings is called a METAR. And METAR stands for Aviation Routine Weather Report. Interesting how they got the abbreviation METAR out of that, but they did. And it provides surface weather conditions at specified locations. They're hourly weather observations at different airports, what the weather is actually doing at the time of the report. And let's take a look at some examples and translate them into English. The surface observation can be a METAR, as it is here at INK, which is a routine hourly weather report. Or it might be a specie like the bottom airport, JFK in New York. And a specie, believe it or not, is a special aviation weather report. Now, the airport identifiers comply with the international standard. So the K in front of the regular three-letter identifier indicates that it's a U.S. airport. We have KINK, which is Wink, Texas, KBOI for Boise, Idaho, KLAX for Los Angeles, KMDW for Chicago's Midway Airport, and KJFK for New York's Kennedy Airport. Let's take a look at that report for KMDW and note the date and time, which is the information just after the airport identification. It tells you what day the observation was made. That's the first two digits, in this case the 12th of the month, and it also tells you the time it was taken, in this case 1856 Zulu. Now, the order in which the information is presented will look like this. First, you'll see the wind. Then you'll see the visibility, then what's called significant weather, which is that stuff that's blowing around in or falling out of the sky. Basically, significant weather is precipitation or obstructions to visibility. Next, you'll see cloud cover, followed by the temperature and dew point given in degrees C, and then the altimeter setting, which will be preceded by the letter A for altimeter, and finally come the remarks. Now, not every item will be there every time. For instance, there may not be any significant weather to report, no precipitation or obstructions to visibility. There may not be any remarks, but if the information's reported, that's the order you'll see it in. Now take a gander at KJFK, the bottom one, and let's take a look at the wind information. The wind is the first group of information after the date and time. Now, the wind is reported as a 5-digit number. The first 3 digits are the wind direction, 180 degrees relative to true north. The last 2 digits, the 04, are the wind velocity, in this case 4 knots. And you know it's in knots because it says so right here with the KT for knots. Now, sometimes, however, the wind can be gusty. Take a look at the top observation, the one for KINK, for wink, where the wind grouping is a little bit more complex. The wind here is from 110 degrees at a velocity of 12 knots, but it's gusting, G for gusting, to 18 knots. Now, what if you want to know if a particular airport is reporting VFR weather? Well, you need to look at the visibility and the cloud cover and see which airports have at least 3 statute miles visibility and at least a 1,000-foot ceiling. So let's take a look at Wink, INK, that top report. And Wink is reporting 15 statute miles visibility with a clear sky, SKC for clear. That's very clearly, very definitely VFR weather. Now take a look at Boise, the second one down. Boise is reporting 30 statute miles visibility with a scattered layer of clouds at 15,000 feet. By the way, you add 2 zeros to these numbers to get the cloud height. So the 150 stands for 15,000 feet. And again, that's good VFR conditions. Take a look now at the METAR for Los Angeles, KLAX, which is the middle report, and let's move across and take a look at their visibility and cloud cover. And what you find is that Los Angeles is reporting 6 statute miles visibility, and the BR here stands for mist. Think of the BR as standing for baby rain. It's like fog, but it doesn't affect visibility nearly as profoundly. Los Angeles also is reporting scattered clouds at 700 feet and another scattered layer at 25,000 feet. Now, do either of these scattered layers constitute a ceiling? I can hear you asking that. No. Remember that a cloud layer needs to be broken or overcast in order to qualify as a ceiling. Remember, too, that cloud layers are reported as above ground level, not above sea level at the airport. So Los Angeles is also VFR. Maybe not great VFR, but it is VFR. Now let's take a look at the weather for Chicago Midway, KMDW, which is the second from the bottom. At Midway, the visibility they're reporting is 1 1/2 statute miles, which is considerably less than the 3 miles that you'd need for VFR. So Midway is definitely not VFR. Now the RA here stands for rain, and it's the significant weather that was occurring at the time of the observation. Not only do you have rain, you also have an overcast cloud layer at 700 feet. And because it's an overcast, it does constitute a ceiling. Also, because that ceiling is less than 1,000 feet, you now have another reason why Midway is IFR. Now notice on that visibility that is 1 1/2 miles visibility. It is not 11 variable to 2. That's an easy mistake to make. Now let's take a look at the report for KJFK, which is the bottom report, and let's take a look at their visibility and ceiling. The visibility, when you take a look at it, is lousy. It's only 1/2 statute miles. And they're reporting that their significant weather is FG or fog, which definitely is an obstruction to visibility. And that the runway visual range, the RO4, the runway visual range on runway 4 is 2,200 feet. By the way, RVR is a means of measuring visibility for IFR operations. They're also reporting an overcast cloud layer at 500 feet. Remember, you add 2 zeros to whatever number you see there. This is definitely not VFR weather. Let's go ahead and finish off reading the report. Next, you find the temperature, which is 20 degrees C, and the dew point, which is 18 degrees C. 20 degrees C is about 68 degrees Fahrenheit, and the dew point of 18 degrees C is about 64 degrees Fahrenheit. The next item is the altimeter setting, and you can always recognize it by the A in front of it. Put a decimal point in the middle of those 4 digits, so the altimeter setting here is 30.06, and that's what you'd enter in the altimeter setting window of your 747 if you were departing from Kennedy Airport in New York. Take a look now at the Midway report just above there, but look at the far end of that line, the remarks section, RMK, and notice that it says RAB 35. RA stands for rain, the B for began, and 35 is the time it started. So the rain falling on Midway's plains began at 35 minutes past the previous hour in Zulu time. And as we saw earlier, the time of the Midway observation is the 12th day of the month at 1856 Zulu. Now the observer knew that the rain began 35 minutes past the previous hour, which was 1800 Zulu. So if this observation was made at 1856, as it was, then what time did it begin raining? It must have begun raining at 1835 Zulu. So armed with this new language, you'll be able to amaze your friends with your translation skills and remain safe and informed about the weather. You'll also be able to look those same friends in the eyes and mean it when you tell them that while all they ever do is complain about the weather, the government actually did something about it.